So the topic for this video is fission versus fusion. Now our sun produces a lot of energy, and you can feel that energy on a nice sunny day. We also use that energy in many different ways. Our sun is pretty average when you compare it to other stars. There are other stars out there that produce a lot more energy than our sun does. Which kind of gets me to our question for the video. Well, how do stars create all that energy? Well, we've kind of already discussed this topic during our energy unit, and our answer lies buried deep within the atoms themselves. Now, if you remember, nuclear power plants generate a lot of energy from just a small amount of material. When we discussed this earlier, we just described this as a process, as nuclear reactions. Well, now we need to be a bit more detailed because there are several different types of nuclear reactions. Let's discuss the reaction that happens in nuclear power plants. It's called fission. During this process, neutrons collide with the nucleus of an atom, making that atom very unstable. We know that atoms want to be as stable as they can, so this new unstable atom that was just created by the addition of neutrons splits apart into two smaller, more stable atoms. When the large atom splits into the smaller ones, also a massive amount of energy is released. This energy can then be changed into electricity, which we can then use. Now, the word fission just means to break apart. Now, getting back to the sun, you should remember that the sun creates 99% of all of the energy that we need. You know, the food that we eat, the gas that's in our cars, all of that energy can be traced back to the sun. So if we trace that energy back just one step further, leads us to the question, where does the sun get that energy? Now, before we can answer that, we need to remember that the sun is the closest star to us. The next closest star is, the name of it is called Proxima Centauri, and that star is 4.2 light years away. There is no way we're getting close enough to study that star. So we have to use our sun as our example. All of the information that we gather from our sun, we can then use to relate to other stars in our universe. Okay, now let's get back to our burning question. Did you get it? Burning? Does the sun actually burn? Well, we'll find out. Now, stars create their energy through the process called fusion or nuclear fusion. When you fuse something together, usually you're just taking two separate things and combining them. This is pretty much what's happening during nuclear fusion. In this case, the two things that are being fused together are atoms. Well, specifically, it's the nuclei of the atoms. When this happens, a larger atom is created. Also, as you can see in on your screen, gamma radiation is also created. You already know that gamma radiation is the highest energy radiation on the electromagnetic spectrum. So let's take a deeper look at what is happening and why this does not happen in nuclear power plants. Well, first of all, you should remember that an atom is determined by the number of protons in the atom. So if you add protons or combine protons, you should get a new atom. In this case, most stars begin as lots and lots of hydrogen atoms. Hydrogen has one proton, so if you put two hydrogen atoms together, how many protons does the new atom have? Well, 2. The only element on the periodic table with 2 protons is helium. Fusion happens in stars because of the very high density, temperature, and pressure put those things together, put the nuclei together. And the density of the sun is so high, 160 times that of water. That's going to allow everything to fuse. Now, stars are extremely large objects. Even though stars are just big balls of gas, there is so much mass there. Now remember, anything that has mass also has, you guessed it, gravity. With so much gravity, you might think that all of the gas particles would get pushed towards the center and the star would collapse and be really, really tiny, really small, because gas particles are small. Well, the pressure created from all of the nuclear fusion reactions pushes against the force of gravity. Now, as you can see on your screen, the green arrows are from the force of gravity. from all of the gas particles, and the red arrows show the force of pressure created by fusion. Now for this star, the force of gravity equals the force of pressure from fusion, and the star's forces balance each other out, keeping the star as big as it is. Now in this case, we're going to talk about something called the main sequence star. What's going to happen is you're going to take hydrogen atoms, fuse them together just like we talked about, creating helium. And when they fuse, they also release lots and lots of energy. Okay, and the energy that's being released in this case is that gamma radiation. So main sequence stars fuse hydrogen into helium to get its energy. Other stars, like red giants, what's going to happen is, well, maybe you've been thinking about this. What happens when the star fuses all of its hydrogen? Does the fusing stop? Does the star blow up? Does it implode? I mean, what happens? Well, if you have a lot of helium, use it as your fuel and fuse the helium together. So when you fuse two helium atoms together, you end up with a bigger atom. 2 plus 2 is 4. The element on the periodic table that has 4 protons in its nucleus is carbon. Okay? Plus, you get more energy. Okay? So, fusing things together, keep fusing them until you can't anymore.